Section 4.1, Dividing Polynomials. In this section, we're going to take a look at two methods for dividing polynomials, long division and synthetic division. Before we do that, let's quickly take a look at some stuff we already know from algebra. Okay, let's say that I ask you to divide 9 by 2. Okay, in old school we will learn to do what? We write it this way, 9 divided by 2. We ask ourselves how many times does 2 go into 9. In this case it's 4. We get a 8 over here. Then we subtract. The key thing is we subtract, and then we get 1. Now if you wanted to write this as a decimal, we could put a decimal out here, put a 0 here, and continue the process. But let's say we don't want to do that. So in this case we call this number the quotient, and this is called the remainder. And we can write 9 divided by 2 as follows. Then we can write it as the quotient, which is 4, plus my remainder, which is 1, divided by my divisor. This is what I'm dividing by, which is my divisor. So you can clearly see 9 divided by 2 can be written as 4. If you want to convert that to a decimal, 0.5, which will give you 4.5, because half is 0.5. Or you could leave it just like this. So that's one thing to note that we've done before in algebra. The second thing to note is this. Let's say if I have 15 divided by 3. If I do this time, I get let's make it a bigger number. Let's say 45 divided by 3. Okay, so we get 45 divided by 3. So 3 goes into 4 once, so we get 3. You subtract the 2, we get 1, bring the 5 down. 3 goes into 15 5 times, so we get 15, and then we get 0. So out here the remainder is 0, the quotient is this. So in this case we just write 45 divided by 3 is just 15. Since the remainder is 0, we don't need to do this. That's not required. Okay, so we can skip that because it's 0 divided by 3 is 0. So we do that. But there's some significance here. When the remainder is 0, there's something special that happens. When the remainder is 0, we learn what? This implies what? Since, let me write it this way. Since r, my remainder is 0, it implies that the divisor 3, that 3 is a factor of 45. Factor of 45, that's what it means. So let's take a look at that for a second, what that implication means. That basically means that if I were to factor 45, remember from chapter 1, factoring means what? You want to write something as a product. So if I were to factor 45, one of the factors will have to be 3. So let's think about it. 45 is the same thing as what? 9 times 5. And then 9 is what? 3 times 3 times 5. So you can see one of the factors is my divisor. So what that basically means is that if you write 45 as 3 times 5, and then you divide by 3 like we were doing up here, the 3's will cancel, so you get 3 times 5 is 15, which is going to be my quotient, which is what I had. Okay, so this is a very important thing to note. Anytime the remainder is 0, that basically means your divisor that you're dividing by happens to be a factor of the number you're dividing. Okay, that means if you were to factor that number you're dividing, one of the factors would have to be your divisor. Okay, and we'll come back to that later, but I just wanted to show you those ideas using numbers. We're going to do the same thing using polynomials now. Okay, so let's start. B. So what we want to do is we're dividing polynomials this time. And we've kind of done this before, but we didn't call it dividing polynomials at that time, and there was a reason for that. We did problems like this in chapter 1. They've asked us to simplify the rational expression. They give us problems like this. Rational, if you remember, basically meant that there was a polynomial in the numerator and a polynomial in the denominator. So we had something like this. Let's say they gave us this x squared minus 10x plus 25 divided by x squared minus 25. The way we did this problem, simplifying basically mean what? Make it simple. Get rid of the excess baggage, sort of make it easier to look at. I can factor the top, we get x minus 5 and x minus 5. You can do that using factoring that we learned in chapter 1. And we can factor the bottom, we get x minus 5 and x plus 5. Then we cancel the common factors, so we are left with x minus 5 and x plus 5. And this is what we did before in chapter 1. We stopped at this stage. But what we want to do now is, the reason why we stopped is because at that time we couldn't do anything with it. But now we can still take this polynomial on the top and divide by this, and that's what we want to do. We want to continue this. Okay, we want to continue this process of dividing. We just don't want to stop. So that's what we're going to learn today, is continuing to divide polynomials, where we have a polynomial on the top and polynomial on the bottom. So that's our goal. So here's what's going to happen. We're going to have a polynomial on the top, which I'm going to call n of x, a polynomial in the numerator, that's why the n. And we have a polynomial in the denominator, which I'll call d of x. So these are both polynomials. This is what I'm dividing by. We call that the divisor. So once I get done dividing, like for example, this would be n of x here, this would be d of x. Once I get done dividing those two, I'm going to end up with something just like this. I'm going to end up with a quotient plus my remainder over my divisor. That's what I'm going to end up with. So let's write that down. So I'm going to end up with quotient, which is also going to be a polynomial, plus my remainder, which is also going to be a polynomial, divided by my divisor. So this is what's going to happen when we divide two polynomials. Okay, so that's how we want to write an answer. Quotient plus the remainder over the divisor. Okay, so just remember that when we start dividing using synthetic and long division, that's how we want to write our answers. Okay, alright, so let's take a look at the first method, long division. Long division is exactly the same as what we learned in basic math, how to divide, just like what I did here and what I did here. So that's long division. So we're going to use the same idea when we do long division here. So let's say the best way to teach you long division is to just do it with an example. Okay, so let's say that I have 3x cubed minus 2x plus 5 divided by x squared. I'm sorry, let's do x plus 2. I'll do one with x squared in a second. Okay, so that's what I want to do. I want to divide this polynomial, we call this n of x, and this polynomial I'll call it d of x. And by the way, the n of x and d of x basically means these are functions of x. You can think of these as polynomial functions. So we call all of these, we call n, d, q, and r. They're basically functions. I'm sorry, they're polynomial functions. Okay, that means a function is basically a polynomial. Okay, kind of like this. This is a polynomial function, and so is this in the bottom. So I want to divide those two. Now, the key to long division is basically, the most important thing is if there is a term missing, if you notice there's an x cubed and then there's an x to the 1, there's an x squared term missing. Anytime there's a term missing, you want to put a placeholder. Even in the top or the bottom, anytime a term is missing, we always want to do that. So in this case, I would write this way. I have x plus 2. I have 3x cubed minus, plus 0x squared, there's a term missing, minus 2x plus 5. It's just a dummy placeholder, that's all it is. 0 times x squared is just 0, so you're not doing anything. Okay. Now, how do we do this? What did we do earlier today? We asked ourselves how many times does 3 go into 45 into 4? 1, so we put down a 3 and so on. So we want to do the same thing here. How many times does x go into 3x cubed? Well, what can I multiply this x by to make it 3x cubed? It'll be 3x squared. So that's what we are looking for. 3x squared times x is 3x cubed. 3x squared times 2 is plus 6x squared. Okay. Then we're going to subtract just like we did before. Out here we subtracted, correct? So we're going to do the same thing, except we have to be careful here. What are we doing here? Technically we are taking the polynomial on the top, which is this 3x cubed minus 2x plus 5, and we are subtracting the bottom polynomial, which is 3x cubed plus 6x squared. Anytime you subtract polynomials, what do we always have to do first? We have to distribute the sign, the negative sign. And what does that do in essence? It basically changes the sign. For example, this is a plus, so it'll become minus 3x cubed. This is a plus, it'll become a minus 6x squared. For example, if this was negative 6x, then this will become a positive when we distribute, right? So all this negative sign does is it changes the signs on the inside. And that's what we need to do here before we continue this long division. So out here this was a positive, so this will become negative because we'll have to distribute the sign, and this will become negative. Okay, so now let's add 3x cubed minus 3x cubed will cancel. Then you'll get negative 6x squared minus 2x plus 5. Okay, so what can I multiply this x by so it becomes minus 6x squared? So does x go into negative 6x squared? Sure, it goes into it 6x times, negative 6x times, because negative 6x times x is negative 6x squared. Negative 6x times 2 is negative 12x. Okay, so we basically want to know how many times does x go into negative 6x squared. It's negative 6x times. Okay, or ask yourself, another way to ask that is, what should I multiply this x by so it'll become negative 6x squared. It's negative 6x. Then you subtract the 2 again, this polynomial on the top, subtract it from this polynomial on the bottom, so we distribute this negative, so this will become a positive, this will become a positive, so this will cancel. So negative 2x plus 12x is 10x plus 5. So then we ask ourselves, how many times does x go into 10x? It'll be plus 10 times. So we get 10x plus 20. Okay, then we subtract again. This becomes negative, negative, this cancels, so you get negative 15. Ask yourself, how many times does x go into negative 15? It cannot, because there's nothing I can multiply this x by to make it negative 15, so we are done. Whenever you cannot do the process, you're done. This is my remainder, and this is my quotient. So how do we write an answer? If I were to divide this polynomial on the top by this, I write down my quotient first, which is 3x squared minus 6x plus 10, plus my remainder, which is negative 15, divided by my divisor, which is x plus 2. So there's your answer to this problem. And that's how we do long division. Okay, let's take a look at another example. This time, let's make it a little bit more interesting by having a term missing from the divisor also. So let's do that. So let's say if I have 4x cubed, no, let's do 4x to the 4th minus 5x cubed plus 1 divided by x squared minus 3. Okay, so let's see if we can do that. So let's create a little long division symbol. So we are dividing by x squared plus 0x minus 3. Remember, there's a term missing here in the divisor, so we need to put a placeholder. There's 2 terms missing in the numerator, so we do need 2 placeholders there. And those placeholders are very crucial. Okay, so now we ask ourselves, what can I multiply this x squared by to make it 4x to the 4th? So it'll be 4x squared. 4x squared times x squared is 4x to the 4th. 4x squared times 0x is just 0x cubed. I'll just write that because 0 times x cubed is just 0, so it really, again, doesn't mean anything. 4x squared times negative 3 is minus 12x squared. and then we're going to subtract. So basically what that does is make this positive a negative, make this a negative, make this a positive. So this cancels. So we get minus 5x cubed, because you have negative 5 minus 0 is just that, plus 12x squared plus 0x plus 1. Okay, now let's go ahead and continue this. So what should I multiply this x squared by to make it a minus 5x cubed? It's a minus 5x. So you get minus 5x cubed. Minus 5x times 0 is just 0x squared. X times x is x squared. Negative 5x times negative 3 is a positive 15x. Subtract again. This becomes a positive. This becomes a negative. This becomes a negative. This cancels. I get 12x squared minus 15x plus 1. Once again, what can I multiply the 12x squared, x squared by to make it 12x squared? It'll be plus 12. So you get 12x squared plus 0x minus 36. Subtract the 2. This becomes negative, negative, positive. This cancels. You get negative 15x plus 37. What can I multiply this x squared by to make it negative 15x? Nothing, because there's no way you can make an x squared into an x, because that's what we have here. So we are done. This is my quotient. This is our remainder. So the answer is what? You have 4x squared minus 5x plus 12, my quotient, plus my remainder, which is 15x plus 37, divided by your divisor, which is x squared minus 3. Okay, so there's your answer to that problem. It's just that we cannot divide any further, so we still need to write it in that form. But we did divide it quite a bit up here. Okay, so we take a look at two examples of long division. Let me go ahead and talk about this factoring business that I mentioned earlier with numbers. Okay. So before I go any further, just remember, when you're doing long division, if there are terms missing, please make sure you guys put placeholders. Okay, those are important, because without that you won't be able to match up the variable terms. If this is an x squared term, x squared, you want to match them up vertically. So if you don't have those placeholders, it's going to be hard. Like for example, if I didn't have this placeholder, then you might be tempted to put this 12x squared there and then add these up, and you cannot add them up because this is 12x squared, this is x cubed. Okay, so there's a reason why we have those placeholders. Okay. Actually, before I talk about factoring, let me go ahead and talk about synthetic division, then we'll come back to factoring stuff. Okay, so let's talk about synthetic division. So we took a look at long division, but there's another way to divide polynomials, is synthetic division. But there's one drawback to synthetic division. Synthetic division only works if the divisor has degree 1. Okay, can only be used if the degree of the divisor is 1. That is, the divisor is a linear polynomial. So that's the only time it works. Okay, so that is one of the most important things about synthetic division. For example, in this problem that I just did, the degree of the divisor was 2. I could not use synthetic division to do this problem. But on the other hand, this first problem that I did, okay, the degree of the divisor was 1. I could use synthetic division to do that problem. Okay, so that's one of the things you should always remember about synthetic division. The other thing to remember, this is the most important thing, but the other thing to remember when dividing, we actually divide by the solution to the equation dx is equal to 0. So we don't divide by dx like we do with long division. We actually divide by the solution to the equation dx is equal to 0. That means you take your dx and set it equal to 0, and whatever the solution to that problem is, that's what you actually divide by. Okay, so that's what synthetic division is. So let's take a look at an example of synthetic division. Let's see if I have this. If I have 3x to the fourth minus 2x squared plus 1 divided by x plus 2. The degree of the divisor is 1, so I can use synthetic division. Okay, so the way we do synthetic division is this. We actually do not work with the variables. We actually work with the coefficients, the numbers in front of the variables. So we create an L that has 2 rows. Okay, in the first row we write down the coefficient of the polynomial we are dividing. So we have 3, but then there's a term missing, the x cubed term is missing, so we put a 0. Then we have negative 2, then there's an x term missing, we put a 0, then we have a 1. Okay, so when we do synthetic division, we are working with the coefficients. If there are terms missing, we still put placeholders. And then what do we divide by? We divide by the solution to this equation when we take the divisor and set it equal to 0. So we solve this for x, so we get x is equal to negative 2. So we actually divide by negative 2, not by x plus 2, but by negative 2. Okay, so let's do this. Alright, in the first column, in the second row, we always put a 0. We always start with a 0. Then we add that column, we get 3. Then we multiply negative 2 by 3 to get the next column. So negative 2 by 3 is negative 6. So we bring down, add that column, we get negative 6. Negative 2 by negative 6 is positive 12. We add that column to get 10. Negative 2 by times 10 is negative 20. We add that column to get negative 20. Negative 2 times negative 20 is 40. We add that column to get 41. Okay, this last row number represents the remainder. Excuse me. Okay, and the first few numbers here represent the quotient coefficients. Remember, we are only working with coefficients. Now here's one other thing to remember about synthetic division. Since we started with degree 4, we were dividing a degree 4 polynomial by a degree 1 polynomial. The degree we end up with for the quotient is always going to be 1 less, because you're getting rid of one of the degrees. So you're going to end up with degree 3. So these are the coefficients of degree 3. So my quotient is this. My quotient is 3x cubed minus 6x squared plus 10x minus 20. So those are the coefficients of my quotient. So my answer is going to be 3x cubed minus 6x squared plus 10x minus 20 plus my remainder, which is 41, over my divisor, which is x plus 2. So there's the answer to this problem. Okay, so when you do synthetic division, we are basically just working with the coefficients, and then when we are done, the numbers we end up with represent the polynomial of 1 degree less than what you started with. If you started with degree 4, this is degree 3 polynomial. If you start with degree 3, this is a degree 2 polynomial, and so on. Okay, let me do one more example. So let's say I want to divide x cubed minus 9x squared plus 27x minus 27 by x minus 3. Okay, again this is degree 1, so I can use synthetic division. So let's do that. In the top row, I just write down my coefficients. I have 1, minus 9, 27, 27. I'm going to divide by the solution to this, or when this will be 0, which is 3. Because you have x minus 3 is 0, so you get x is equal to 3, so you're going to divide by 3. Okay, so I get 0 here, 1, 3 times 1 is 3. I get negative 6 when you add that column. 3 times negative 6 is negative 18. When you add that column, we get 9. Okay, so we get 3 times, oops, this is a negative 27. 3 times 9 is 27. When we add that, we get 0. So since we started with degree 3 polynomial on the top here, these are the coefficients of a degree 2 polynomial. So my quotient is x squared minus 6x plus 9. Okay, so I can rewrite this as x squared minus 6x plus 9. I don't need to write anything else because the remainder was 0. Now before I go any further, I mentioned something about when the remainder is 0. What does that tell you? So this implies that x minus 3 is a factor of x cubed minus 9x squared plus 27x minus 27. That means if you were to factor this, and remember what factoring is, writing it as a product, if you were to find two polynomials, when I multiply to get this, then one of those polynomials would be x minus 3. Okay, so anytime the remainder is 0, you can do that. They could have asked you this question. Instead of telling you to divide this polynomial by this, they could have asked you, is x minus 3 a factor of this polynomial? That means basically you want to do long division or synthetic division to see if the remainder is 0. If the remainder is 0, then yes, x minus 3 is a factor of that polynomial. If the remainder wasn't 0, then x minus 3 is not a factor of that polynomial. Let me show you why that works. So let's say that I'm dividing nx by, let me actually write this down, create a theorem first. Theorem which states that if, okay, n of x is divided by x minus c, and the remainder, I'm sorry, not x minus c, d of x, and the remainder is 0, then d of x is a factor of n of x. Okay, and you can see that from here. So let's say if I take n of x and divide it by d of x, okay, I usually get what? R of x plus some remainder, I'm sorry, q of x plus some remainder r of x divided by d of x. That's what we end up with. But let's say that now, let's say let r be 0, the remainder be 0. Then what happens? I get n of x still over d of x is equal to just q of x now, because r is 0, so this term is gone. This is 0 now. Okay, now I have this over 1 technically, so I can cross multiply. So I get n of x is equal to q of x multiplied by d of x. So you can clearly see we have taken this polynomial n of x, the one in the numerator, and we've factored it because we've written it as a product of two polynomials, this and this, where one of them is a divisor. That means your divisor is one of the factors of n of x. That means if you were to factor n of x, one of the factors would be the divisor. So you can clearly see that from this little argument. So a theorem, again, I think I've mentioned this before, is a statement that has mathematically been proven rigorously. So this basically tells you is anytime the remainder is 0, that means your divisor is a factor of your numerator, what you're dividing. Okay. Alright, so let me ask you this question then. Okay, so here's a question. Is, okay, I could ask you, is x minus 1 a factor of x cubed plus 2x squared minus 2x minus 1? So here's the question. Well, the only way you can answer this question is if you there's two ways you can answer this question. One is you can actually factor this, and if one of the factors happens to be x minus 1, then you're done. Okay, or you could try to take this polynomial and divide by this polynomial. Okay, and if the remainder happens to be 0, then you know it's a factor. So I'm going to do the division. Since this is linear, I can divide using synthetic division, or I can also do long division. Synthetic division is always faster, so I always prefer that. So you get 1, 2, -2, -1, divide by 1. Remember, you're dividing by the solution to this equation when x minus 1 is 0. So we get 0, 1, add the column. 1 times 1 is 1, we get 3. 1 times 3 is 3, we get 1. 1 times 1 is 1, so we get 0. So what does that tell me? They didn't ask us to actually find the quotient or anything. They just wanted us to check to see if this is a factor of this polynomial. And since the remainder is 0, so that implies what? Yes, x minus 1 is a factor of x cubed plus 2x squared minus 2x minus 1. I can even do one better. According to this, what is if the remainder is 0, then what can we also do? I can take my numerator and write it as what? My quotient multiplied by my divisor. So I can actually factor this. I can write it as a product. So let's do that. So I can write x cubed plus 2x squared minus 2x minus 1. That is what you were dividing. We were dividing this by x minus 1. That's what we were doing. So what does that tell me? This is equal to my quotient. Here's my quotient, the coefficient of my quotient. We started with degree 3, so these are the coefficients of degree 2. So we get x squared minus 3x plus 1 times x minus 1, my divisor. So we clearly have factored this. And this is important to note because we did learn a few techniques for factoring in chapter 1, but none of those techniques would help us factor this polynomial. Okay, because it's something we just don't know how to factor. But by dividing this, if someone came and told you, hey, check this to see if this is a factor, once we know it is a factor, then we can definitely write it down as that. So we wrote it as a product, so we factored this polynomial. Okay. Alright, there's one other theorem that's associated with this section, so let's talk about that, which states that if n of x is divided by a linear polynomial like this, x minus c, then the remainder is n of c. So this is another way to find the remainder. But remember, you already know two ways to find the remainder. You could do synthetic division, the remainder is right there, or you could do long division and the remainder is right there. So you do know two ways to find the remainder. Here's a third way to find the remainder. If I take a polynomial n of x and divide it by a linear polynomial x minus c, then the remainder is given by n of c. So let's test that just to see if that works. Okay, so let's say that they tell us that we have minus 4x cubed plus x squared minus 2x plus 7 is divided by x plus 2. And they've asked us, here's a question, find the remainder. Okay. Now they could have also asked us this question this way. They could have said that, you know what, n of x is this. Okay. And x is equal to -2, find the remainder. Okay, that could have been the same question. Okay, so now let's find the remainder. This is my n of x. Just so you guys know, the polynomial in the numerator is always called n of x. So one way to find the remainder is what? This theorem that tells us what? you replace x with c, where c is this number here. Well, you have to be careful there. Out here the theorem is x minus c, out here is x plus c. So negative c is equal to positive 2. So we have negative c is equal to 2. So c must be negative 2 if you divide both sides by negative 1. So c is actually negative 2. Okay, so I want to find n of negative 2. So in this polynomial n that I have in my numerator, I want to replace all the x's with negative 2. So we get negative 4 times negative 2 cubed plus negative 2 squared minus 2 times negative 2 plus 7. So I end up with negative 4 times negative 8 plus 4 plus 4 plus 7. So negative times negative is 32 plus 8 plus 7. I added up these two 4's. So we get 47. So there's my remainder. Okay. So you can see we can find the remainder using this nice theorem, which tells us that anytime you divide a polynomial n of x by a linear polynomial, the remainder is given by n of c, where you replace x with c. The key thing is, remember, there's a negative here, so you have to compensate for that. I could have also found my remainder, like I said, two other ways, by synthetic division or long division. So let me do that to check this answer. So I'm going to have negative 4, 1, negative 2, 7. I'm going to divide by negative 2. So I get 0, negative 4. Negative 2 times negative 4 is 8. We get 9. Negative 2 times 9 is negative 18. We get negative 20. Okay. Negative 2 times negative 20 is 40. So we get 47, which is my remainder, which is what I had. I prefer doing synthetic division. If they ask me to find the remainder, I just do synthetic division. It's easier, okay, than trying to do this stuff. But you do have another way to find the remainder. So in this section we learned two different ways to divide polynomials, synthetic and long division. Just remember a couple things. Long division always works, but synthetic division only works if the divisor has degree 1 or it's linear. Okay, so keep that in mind. In both cases, if there are terms missing, make sure you guys put placeholders. And then also with synthetic division, you're actually not dividing by the d of x, a polynomial in the denominator. You're dividing by the solution to this equation, where you take the denominator and set it equal to 0. Okay. The other thing to note from this section is about the factor theorem. Where did I write it? Oh, here. Which states that if you divide a polynomial n of x by d of x and the remainder is 0, then that tells you that the divisor d of x is a factor of your numerator. That means, and you can see that I've shown you that out here, that means the polynomial in the numerator can be written as a product, because factoring means writing it as a product, can be written as a product of the quotient and the divisor if the remainder is 0. So the question could be asked, is x minus 1 a factor of that? So you can divide the polynomial by x minus 1. If the remainder is 0, then the answer is yes. If it's not 0, then it's not a factor. And if it is a factor, then we can take the polynomial in the numerator and then write it as the quotient times the divisor. Okay. Then we also learned another way to find the remainder. We already had two ways to find the remainder, by actually doing long division or synthetic division. And another way to find the remainder is by using the remainder theorem, which states that if n of x is divided by a linear polynomial x minus c, then the remainder is just n of c. Replace x with c. So in this case, if I divide this polynomial by this, then the remainder is just n of negative 2. That's my remainder. I should have put an r here. So there's my remainder. Okay. Remember, this is x minus c. I was dividing by x plus 2, so c is actually negative 2. Okay, so this is negative 2. You see that. And we could have also done synthetic division and found the remainder too.